What is the solid principle? First of all, we have to be know. As the name suggests, it is an abbreviation, and we will discuss each and every point for the solid principle. As a S represent the single responsibility principle, O represent the open close principle, L represent the Liskio substitution, I represent the interface segregation principle, and D represent the dependency inversion principle. So we'll start one by one. First off, we start with the SRP, single responsibility principle. Like normally, most of the people in the interview time they are telling like SRP means that one class has only one reason to change, or sometime one class should have only one public method. If your class has and in the definition, then you are violating SRP, because and means you are performing one and two operation. So as the name suggested, single responsibility means you have to perform one action at a single time. But it is the incorrect way. You can say the same definition like as a proper, I can say correct way. One class must perform a single functionality only, and the clean code, like we can say, we have a one model should be changed by only one actor in the system, and one model should have only one responsibility. Model like a set of function, class, package, source code. I also share the one of the example LLD for this single responsibility after this completion. Next, we have a open close principle. According to the as name is like open close principle. So according to new business requirement, the model should be open for the extension but closed for the modification. This open close principle means this extension allowed to implementation of the new functionality to the model. With the help of code, I can see we have a method, one of the class we have a vehicle, and method we have a vehicle number. So what we are doing was, we are in the class vehicle info, we are creating the one of the method like a vehicle number, vehicle v, and creating the instance and returning the number on that. Similarly, if in the future new business requirement coming and we have to be add the another subclasses named truck, then what we do, we add one more if statement. It will violate the OCP because we will modify. So as per the open close principle, we can't modify, we can extend. So we have to be extend the functionality for this. So what we can do, solution is like one way to add subclasses and achieve the OCP if by overriding the vehicle number method. So correct code, what we can do, I just created the class vehicle info, added the vehicle number method, and in the future the class car we have created, added the class vehicle info extend. Similarly for the bike, similarly for the truck also. So we are inheriting the base property of the vehicle info, and in the future if anything is coming new, we are just extending and implementing our logic. But if we are using the if condition over the previous code, that will violate the our OCP condition, OCP principle. So similarly, we can add the more vehicle by making the another subclasses extending from the vehicle classes. So this approach would not modify the vehicle class and hence follow the OCP. And after the OCP, we have a next Liskio substitution principle, and I can say it is introduced by the Barbara Liskio, and that's by the name. And the main definition of this principle is like it extend the OCP because it is coming after the OCP. So that's why if anything is coming after the, like I can say version 1, version 2, version 3, or iPhone 11, 12, 13. So every feature or every version is coming with some next level feature. So as here also I can say after the OCP, this LCP is we are using, and it is like extend the OCP and also focuses on the behavior function of the superclasses and its subtype. The definition what it means, if a function take an instance of a class, that same function should be able to take the instance of the derived classes from that class. Easier definition I can say, derived classes must be completely substitutable for their base class. It means it never breaks the parent-child relationship in a single meaning. So Liskio principle is used to check if the inheritance is done properly or not. Correct inheritance not violate LSP, but incorrect inheritance violate the LSP. With the help of example, I can see we have a class C, and in this we have a void X method. And we are having another class C1, which is extending the C, C2 extending the C. And in the main method, we are initiating the instance of the C1, C2, and C and calling the X method. So it follows the risk substitution principle. So basis on this risk substitution principle is working. Substitution principle, we have a next interface segregation principle, as I representing for the interface segregation principle. It means like keep the things abstract, hiding details, and let classes implement them. Interface I1 we have created, and there is a two function, get function, set function, and class C1 implements I1. There is a two method you can see we are implementing in the C1 from the interfaces. Similarly for the C2, C3, C4. As per the definition, our interface should not handle a lots of responsibility. So instead, multiple interface should be handling the different responsibilities. So what we can do in the large interfaces, we can split into I1, I2, I3, or like I2 for the small, I3 for the small. I can say if there is a interfaces I created, and in that we are added the three method like into, double, int, converting the double, converting the char, converting the string. So this is no option to implement only a single function as a subclasses. As I can say in the future, I have to be implement only the double method. Then it is difficult for implementing in any other classes because in interface represent the contract. So what we can do in the correct format, what we can do, we can create the different method for that one, like convert into double, convert into char, convert into string. So this is the right way. So large interfaces conversion we are implemented into three smaller interfaces: convert into double, convert into char, and convert into string. So that's for the inversion control. Next we have a dependency inversion principle. And the dependency inversion principle is not same as the dependency injection inversion of control. Dependency inversion principle based on the like dependency injection principle, inversion of control implementation. As per the definition, high level model should not depend on the low level models. Means like we don't have to create any dependency over the application. We have to create the loose coupling, like we can capture at the compile time. I can give the one best example here. Like I can say in the class A, we have a field and method, field type and method type, which is depends on the class B. Similarly, class B depend on the class C. So on any change in the class C would require a change in class A as well as the class B also. It is not a good practice. So while writing the UT or unit test for class A, it have to be focused on the functional aspect of the class A, class B, class C also. So you will need to move the dependency from class B and class C also. So such code bases are difficult to manage, change and test. Such code bases are difficult to manage, change and test. Every time while we are designing code in a dependency inversion, we have to be keep the things, keep the rules correctly.